We're going to call this Lecture 9, although I've done a review for the exam with my class, review for Exam 1 with us, and that would kind of constitute a lecture, and then exam would constitute a lecture, so it's kind of closer to be like the 11th day in a regular 16-week course, but it's okay. In sequence, we'll call it Lecture 9. Then that's what's going to make sense. So, we last talked about, we introduced Chapter 5 in the Hibbler text. That's in many texts. It's going to be equilibrium of rigid bodies, and that I want to introduce kind of this approach for solving equilibrium problems, which I did this with my class in our Exam 1 review. So this is going to be review for some of us, and that's okay because it's really important, right? Step 1 is identify what you're looking for. What is your unknown? What is it that you're after? What is it that's going to constitute a solution to the problem? That's number 1. And this is not unlike, this is kind of an applied version of the basic problem solving that I've really tried to hammer home the last, the whole time we've been having these discussions. Step 2 then is, which has always been what is known in an equilibrium problem, that becomes your free body diagram. That's really step 2. Step 1 is what is it you're looking for. Step 2 is draw a free body diagram where that unknown or those unknowns are going to be, or as many unknowns as you can put on one free body diagram. And then step 3 is to apply, step 3 historically has been what laws, equations, tools do you have that are useful? And for us, it's going to be equilibrium. So for a 2D free body diagram, you have 3 equations. And we're going to talk about writing equations and what equations we can and can't write. But for a 2D free body diagram, you can write up to 3 equations. And what we're going to see as we progress through this content, we're going to talk about 3-dimensional problems. For a 3-dimensional free body diagram, you can actually write up to 6 equations. Now, one might look at this and say, Steve, you said last time it was only 2 equations per free body diagram for 2D. 2 force equations and a moment equation. Now I can take the moments and set the moments equal to 0. And that gives me a 3rd equation. And we're going to talk, we could actually write more than one moment equation. That's a whole nother ball game, but we'll get there. When we do, again, start looking at 3-dimensional problems, you can write up to 6 equations. That's 3 force equations, forces x, y, and z, and then you can write 3 moment equations. Normally we write moments because they're vectors, so we'll write sum of moment vector to be 0, and that means the moment about the x, the moment about the y, and the moment about the z axis should all be 0. That generates 6 equations for us. So more unknowns that we can go after per free body diagram. And again, just like we have done previously, you get down to this point is, can you solve? Can you get to a solution? Is this solvable? And if the answer is no, okay, what is still left? What are you looking for now? What's the unknown that you've either identified a new idea, unknown, or what is an unknown that's still unknown you don't have enough equations for? If you have as many equations as you have unknowns, then just simply solve. Now, I did mention, in addition to equilibrium, position vectors, and basically just kind of organizing your geometry. Your free body diagram should really help you organize your geometry, but if I've got a 3D problem that's going to involve position vectors. I find I prefer, not position vectors, I apologize, it doesn't go there, it goes up here. Position vectors. I wrote it in the wrong place, I'm sorry. I find if I'll do my position vectors first, then I can draw a free body diagram using the position vectors, using the unit vectors from the position vectors to draw the free body diagram where the forces are resolved, especially in 3 dimensions. You'll see when we start writing 6 equations, if the free body diagrams are resolved in x, y, and z components, writing those equilibrium equations are a lot easier, especially in 3 dimensions. In my opinion, if you can write them without resolving them, that's fine with me. It doesn't bother me at all. But that would be my preference. Now, so, just half a second here. Okay, I think we're good. And that does bring up, I alluded to earlier, that you can write multiple moment equations sometimes. So there's this point most textbooks will talk about is we don't always have to sum. Just a second, I am going to pause real quick. We don't always have to sum our moments about an origin or A or the bottom left. If you get kind of in the habit of always taking your moments about the same point, you don't have to, right? You can take moment equilibrium, right? Summing the moments and setting it equal to 0. Moment equilibrium can be applied anywhere on a static free body diagram. If your object, if your free body diagram is not accelerating, its motion is not changing, then you can apply equilibrium and set the moment equal to 0 and add up all the moments. Set them equal to 0. You can do that to any point on a 2D body diagram, and in 3 dimensions we'll be able to do it. A lot of times we'll go about x, y, and z axis, but you can apply it about any point or any axis in 3 dimensions, and the sum should still be 0 for a static free body diagram. What that means is, so that unlocks kind of a new level. New achievement is we can write more than one moment equation per free body diagram. In fact, you can write infinitely many moment equations per free body diagram. The problem is multiple moment equations may yield dependent, read unsolvable, equation systems. So what am I saying there? I'm saying you can, if you don't want to just always write sum of, in a 2D free body diagram, I'm saying sum of forces in the x, sum of forces in the y, and then one moment equation. Well, there's nothing saying you have to write your moment about any specific point. You can write it about any point. And you wouldn't actually have to, if you look at it like, well, what if I wrote a moment about point A and I wrote a moment equation about point B and I set those equal to each other and solve those? Would that work? Yeah, that would work. But again, you can find yourself in a situation where you have a set of dependent equations that you can't solve. You would end up with a true statement. 0 is equal to 0, or one force, unknown force is equal to itself. That you can find yourself in that situation. 2 force equations and 1 moment equation will always be independent and solvable. All right, so you will always be able to write a system of equations with two force equations and one moment equation that will always be in three independent equations that will be solvable for up to three unknowns. That is always true. You could write three different moment equations that could yield an independent set of equations and solve for up to three unknowns. You won't be able to write, you could write two forces and three moment equations and say, hey, Steve, I've got 5 equations for one free body diagram. That's great, but I guarantee you are not going to be able to mathematically solve those for any more than 3 unknowns. You will end up with, in a logic loop where you have a true statement is equal to true statement, because you won't be able to write 3 independent equations, or at least more than 3. You won't be able to write more than 3 independent equations for a 2D, we should caveat that here, for a 2D free body diagram. 2 force equations, 1 moment equation will always be independent. And I guess that's also true for a 3D, because you're going to end up writing more equations than that. Most texts will have some sort of discussion about rules and practices that you can follow if you choose to write more than 1 moment equation for a free body diagram and try to solve it. And I don't remember a lot of those rules off the top of my head. I normally just kind of write them quickly, and if I can't solve it down, I'll go back and write force equations because I know those always work. But there's rules about where the points can be that you take moments about each of those points and how they can be in reference to each other. And again, you're welcome to look at those. If you memorize things very well, feel free to memorize those. At any rate, let's see here. Those are the things I've got in my notes to talk about. Not the worst stopping place. A little short on this video, but I think that's okay. I think I'm going to pick up on the next video. We'll talk about 2 force, 3 force members and move on from there. So we'll talk about that in the next video.